Good day, future engineers. This time we'll be discussing with discrete multiple degree of freedom or MDOF system. In the previous discussion, we have talked about the SDOF system or the single degree of freedom system. In the single degree of freedom system, we have a single story structure, and then we simplify and idealize the structure in order for us to describe the behavior of such structure and to only allow this structure to move on the lateral direction. It will be easier for us to describe the behavior of the structure under free vibrations. So we're going to describe the response of the structure. Now, with the multiple degree of freedom systems, we have also assumptions, simplifications, or idealization of the multi-story building. So as for us to describe the, the behavior of the structure under free vibration response. So here we have the assumptions for our multi-story building and the SDOF system. If you remember, first we have the assumption that the columns are massless or the columns supporting the systems are massless. And then the second assumption is that the inner mass of the structure is concentrated at the floor levels. It is assumed that the columns are massless, and then the mass of the structure is concentrated at the floor level. So it is very important that we try to apply this concept also on the multi-story buildings. The last time we tried to apply this for the SDF system, now we have the the multi-story building. The third assumption is that the floor systems and beams are rigid, whereas the columns are vertically rigid but flexible to lateral distributions. The same also with the SDOF system, we have a flexible floor systems or and beams are rigid, and then the columns are also rigid vertically but flexible only to the lateral deformation. Now, what will happen if the floor systems and beams are not rigid and the column is also flexible on the both the vertical and the lateral direction? So, if the columns and the beam and the floor systems are not rigid, this behavior of the structure and under say dynamic loading or free vibration response will give us something like this. Now, it might behave, this is just an exaggeration, but it might behave as something like this. If you're going to look at this deformation of the single story building, there is lateral motion or sideways motion if we look on this side. Aside from that, if you're going to look at its nodes, there is a presence of vertical direction since the columns are not rigid on the vertical direction but flexible on the vertical direction. And then more than that, if you're going to look at the nodes, there is also rotation present on that specific nodes. So there is rotation, there's vertical deformation or motion, and as well lateral. Now, if this happens, this structure will become complicated. That's why we need to assume that the floor systems and beams are rigid and the column is rigid on vertical direction, but we allow it to move or flexible on the lateral direction so as the structure will only move on the lateral direction, and it will be easier for us to describe the behavior or the response of the structure under, let's say, free vibration response. Then lastly, the structure is supported on the rigid ground. Here on the right side, we have a multiple story building. Now let's talk about the notations that we're going to use throughout our discussion for the MDOF system. Like in the SDOF system, we have also in the multiple story, we'll be dealing also, or we're talking about the masses. The M is our mass on the floor. And then we have also our lateral stiffness K, also present here. And as well, we have also those other notations for the height of the floor, like the H. And then what else? We have also the damping, say. So for this specific structure, let's say if this is the first floor, then we have our mass 1 there, mass for the second floor, so on and so forth up to the other floor. Let's say that is the mass at the J floor, and then the topmost floor, or that is the mass of the nth floor. Now the height supporting the first floor, we'll take note that as our H1. The height supporting the second floor, our H2, so on and so forth. The height supporting the J floor as our HJ, so on and so forth. And then the height of the topmost floor, say HN. Aside that there is the presence of the mass on the multi-story building, there is also, since the column is rigid on the vertical direction but flexible on the lateral direction, we also have the stiffness. Now we have the lateral stiffness uh, for columns carrying the first floor, so on and so forth. Now, in order for us to describe the behavior of the multi-story building, like what we did in the single degree of freedom system, we tried to formulate the equations. Now, we have the equations of motion. So, in the SDOF system, we tried to describe the behavior or the response of the system under free vibration response by describing the deformation of the SDOF, and as well the response velocity and response acceleration of the system, and the damping force, inertia force, and the static or the elastic force present by that free vibration response of the. Now, in a multi-story building, we'll also try to formulate equations of motions, but here in the multi-story building, it is quite different, as we'll not be calculating the what we call this, the response velocity or acceleration of the building, but we are going to describe the shapes, what we call the motion. We'll be discussing that later in our discussion. So the formulation of equations of motions in the MDOF system is by using the direct dynamic equilibrium approach like the SDOF system. So we'll formulate the equations of motions for the MDF system in the next presentation.